What's up, everyone? Today we are back with another lesson based in trigonometry. Um, so obviously geometry subject, but we're doing lessons that have to do with trigonometry at the moment. We did our intro to trigonometry lesson, and now we're going to move into some more specific topics within it, I guess we could say for right now. So we're starting off, and we have a right triangle here, right triangle ART, where angle R is the right angle, and we're given two sides. We're given RA, which is 21 units, and AT, which is 29 units. Sorry, I forgot how to say numbers. So RA is one of the legs, right? That's one way we could think about this. The leg of this right triangle. And AT is going to be our special side because it's across from our right angle. Remember, one way to figure this out is take your pointer finger, touch that right angle, and then drag it across your triangle. When you drag it across your triangle, you'll hit a side. That side is going to be called your hypotenuse. I'm going to abbreviate it as hype, but that's your hypotenuse. And then we don't have this side RT, which is our first question is asking us to find it. Now, one thing to remember with right triangles, we could use our Pythagorean theorem. Now, a lot of us forget what that is. Our Pythagorean theorem is this little statement here. A squared plus B squared equals C squared. What it really means is if we take the two legs in a right triangle, square them, and add them together, it's going to equal our hypotenuse squared. So this long side here. So for this one, what can we do? Well, I'm going to say that RT is A, right? So we're going to say that A squared, that's going to stay our variable, plus our other leg, which is 21. So we'll get 21 squared equals C squared, which is 29 squared, right? Now we just got to plug this to a calculator. Once again, guys, don't forget, one of the best calculators that you guys could use is the Desmos Scientific Calculator, right? You could just type it in online. You could get the app, and it works wonderful. So when we square these, we get A squared plus 441 equals 29 squared is going to give me 841. 841. And then what we have to do is solve for A. So we're going to subtract 441 minus 441. We would do it on both sides. Rewrite everything up here. That's going to leave me with A squared equals 400. And then we take the square root of both sides and we get A equals 20. So we could say right up here that RT is equal to 20. The second warm-up question says, write a ratio to compare the length of the side opposite angle A. So we're going to write opposite angle A over the length of the side adjacent to angle A, ADJ angle A. And when you see a ratio, guys, you could think fraction, right? So ratios could be written in different ways. Sometimes you'll see them written as a fraction. Sometimes you'll see them almost written like time with the two little dots in the middle. There'll be a number, the two little dots, and then another number. That's also a ratio. Unless you are talking about time, then obviously it's time. But we most commonly, for this lesson and for these next couple lessons, we're going to see it as fractions. If it asks you to write a ratio, think, hey, I need to write a fraction. So this one is going to be the opposite angle A over adjacent of angle A. So what side is opposite angle A, right? That's what we need to figure out. Here we have angle A. If I want to go opposite it, I'm going to drag across, and we're going to hit RT, which is 20. So opposite angle A is 20. And adjacent. Now, remember, adjacent means next to. But we have two that are next to angle A here, right? We have 21 and we have 29. So how do we know which one to use? Well, if we notice 29, we gave that special name. That's my hypotenuse. We're not going to use the hypotenuse when we have this leg here. So it's going to be 20 over 21 because RA is the side that's adjacent to angle A. So angle A is known as our reference angle in this one. So that's one thing to keep in mind. Now it says write a ratio to compare the length of the side adjacent to angle A to the length side opposite angle A. So we're flipping this. ADJ, angle A, and opposite angle A. Whoop, equals. So we already know these numbers. We know which ones are adjacent and opposite. So this is just going to flip. It's going to be 21 over 20. So basically, it's just the reciprocal. Remember, that word reciprocal just means when we flip a fraction. Awesome. So here's a little warm up. We got some vocabulary going through our brains. Feel a little good. So our lesson today is called the tangent ratio. No fun name here, right? I mean, tangent's kind of fun, but we're going to be talking about the tangent ratio, the cotangent ratio, and the inverse tangent. So we're going to define relationships between the lengths of opposite sides and the adjacent side in a right triangle, and it's going to be known as our tangent ratio. We're going to relate the tangent ratio to the cotangent ratio, and we're going to use the tangent cotangent ratio to solve problems, and we're going to use the inverse tangent in a right triangle to solve for unknown angle measures. We're going to be getting a lot thrown at us today. So if you need to pause and take time throughout this lesson, feel free, right? There's a lot going on. So let's start out with our first thought process here. It says connect slope and tangent. The maximum incline for a safe wheelchair ramp should not exceed the ratio 1 to 12. This means for every 1 unit vertical rise requires 12 units horizontal run. And now already we see that rise and run. That should make us think of slope, right? Rise and run makes us think of slope. Slope's a fraction. Things are coming together here, people. The maximum rise for any run is 30 inches. The ability to manage the incline of a ramp is related to both its steepness and length. And we have a little picture of a ramp going into what looks like a restaurant, right? So Troy decides to build 2 ramps, each with a 1 to 12 ratio. The first ramp extends from the front yard to the front porch. The vertical rise from the yard to the porch is 2.5 feet. And it says calculate the length of the surface of the ramp. Well, we already have our run. Our run is going to be 30 here. What we want to know is the surface of the ramp. So once again, we have a right triangle here. We have 2 of our legs. We could use that thing that we used in our warm-up, the Pythagorean theorem. We're going to say a squared plus b squared equals c squared. And this one's going to be actually easier because c is our hypotenuse. That's the one that's missing. So I could plug 2.5 and 30 in for a and b. We're going to say 2.5 squared plus 30 squared equals c squared. And now we just have to solve. So once again, go to your calculator. 2.5 squared gives me 6.25. Whoops, sorry about that. Gives me 6.25 plus 30 squared will give me 900. Oh my God, it keeps doing this. 900 equals c squared. And then we just add these. It's going to give me 906.25 equals c squared. And last but not least, we take our square root. That is the opposite of squaring something. So in your calculator, you put in square root of 906.25. Enter. We're going to round to the nearest tenth here because in our problem, we have a decimal that's to the nearest tenth. We're going to do the same thing. So that's the first decimal place. So we're going to get C on our right side, and on our left side, when we take the square root of 906.25, we get 30.1. And there's our answer. That is our ramp length, 30.1 feet. Next up. The second ramp extends from the deck to the back of the house, or to the backyard, sorry. From the deck on the back of the house to the backyard. I was like, I thought I read something right. The vertical rise from the yard to the deck is 18 inches, right? So if it's 18 inches, we get that 1 to 12 ratio. That means our run has to be 216 inches. It then says calculate the length of the surface of the ramp. right? Once again, this is a 1 to 12 ratio here. If we weren't given the run and we only knew the rise, we could do 18 times 12. It's going to give me 216. So once again, we just do our Pythagorean theorem. A squared plus b squared equals c squared. You plug it in, we get 18 squared plus 216 squared equals c squared. Once again, why are we leaving c as a variable? Because we don't know our hypotenuse. That's what we're looking for. The length of the ramp is our hypotenuse. So we have to square 18, and we have to square 216. We're going to get big numbers here, people. And so 18 squared is going to give me 324 plus 216 squared is 46,656, which is going to equal c squared. Now we just have to add these two numbers together. So we got 46,656 plus, that's going to give me a nice big number, 46,980 equals c squared. Once again, we take the square root of both sides. And when we get square root of that, it's going to give me a decimal again. And that's going to give me c equals 216 point, and I'm going to round this to the hundredths place now. And you might say, yeah, but we rounded the last one to the tenths place. Why are you rounding this one to the hundredths place? We don't have any indication, right? We don't have any decimals in our problem here. When we don't have any decimals, we go with the safe bet and we go to the hundredths place, right? So that's the second decimal place. So in our calculator, we have 216.7487024, right? So if we round to the second decimal, it's really going to be 216.75. There's our answer. 216.75. Awesome. Let's keep it cruising. So, compare the two ramps. Are the triangles similar? Explain your reasoning. We want to know, are these triangles similar? Well, we need to think about our similarity ratios, right? Or similarity shortcuts, I mean. So one of them was side, angle, side. And what this meant was sides that are proportional, angles that are congruent, sides that are proportional. And we need to see, do we have that here, right? So we could say 2.5 over 18. And then what is that equal to? And then we could do 30 over 216. What is that equal to? Right? So we're going to get decimals for these because they'll just be easier to compare. So we do 2.5 divided by 18. That's going to give me 0.138 repeating. So 0.138, and we're going to round it to 9. And then we do the same thing for the next one. 30 divided by 216. And that's going to give me the same number, which means that these two sides are proportional. So we get 0.1389. So they're proportional. They equal the same thing. And then what do we know? We have these right angles in between them, which means they are congruent. So these triangles, yes, they are similar by side, angle, side. So our next question says, what does the ratio of the rise of the ramp to the run of the ramp represent? And what we could think about that is they represent slope, right? So the rise of the ramp to the run of the ramp, it's our rise over our run that represents our slope. So we could say, hey, slope, or the steepness of the ramp, right? Of the ramp. And this says compare and describe the angles of inclination of the two ramps. Well, if these have the same steepness, we might be able to assume that these angles here are also congruent. But we also know that they have to be, right? Because these two triangles are similar. In similar triangles, their corresponding angles are congruent. The angles are congruent. That's interesting because we have such drastic numbers, right? Here we have our rise or our height 2.5. Here we have our height 18 inches. Here we have our length 30 feet. Here we have our length 216 inches, right? They're so different, but they have the same angle of inclination. And why? Because they're in similar triangles. Similar triangles have congruent angles. So what we actually just looked at here too, those ratios is known as our tangent, right? So the tangent of an acute angle in a right triangle is the ratio of the length of the side that is opposite the reference angle to the length of the side that is adjacent to the reference angle. The expression tan A means tangent of angle A. So guys, you're going to see tan A, right? We're not going to call it tan A. I said it there just to read it, but it's called tangent A, right? So you'll say tangent of angle A. That's how you'll say it. Just because it says tan A right here, just in case you're missing out, right here it says tan A. We're going to read it as tangent of angle A. The tangent of the angle can be used to describe the slope of the line, just like what we said, right? So here we have our reference angle in this picture. We have our opposite side, which is our rise, over our adjacent side, which is our run. So it's opposite over adjacent, which is really like our rise over run. They're the same thing. So basically, what we're doing today is just slope. It has a fancy name, and we're calling it the tangent, but it's just slope. So if we look at this example here, we have this triangle ABC, and they're saying consider angle A in the triangle shown. So this is our reference angle. Sometimes you guys are going to see they'll put this little symbol like this, right? That's called theta. It's a Greek letter. So that just means that's our reference angle, which means then we draw that line across. This is my opposite side. This is my adjacent side because it's right next to our reference angle, and then across from my my right angle. Let me do this in purple. Here's my right angle, right? It like draws an arrow. This is gonna be my hypotenuse, right? So with that information, it then says the tangent ratio describes the relationship between angle A, the side opposite angle A, and the side adjacent to angle A. So the tangent of angle A equals the length of the side opposite angle A over the length of the side adjacent to angle A, which we labeled. So basically we could say it's really just equal to BC over AC. And this is our tangent ratio. So let's see more examples with this, right? So here, it's now asking us, be careful, if we're using angle B, right? So I'm going to draw my little theta in here just so we can see which one we're talking about. So that angle right there with theta in it, that's angle B, right? So the side opposite angle B is now going to be, that's AC. So length of the side opposite angle B, we're in this box, we're going to put AC. Cool. And then adjacent to, which means right next to, ADJ, is going to be BC. And once again, some of us might be confused. Well, AB is next to angle B, right, mister? Yeah, but it's also got that special name, so it's not going to be our adjacent side. Since it's across from our right angle, this is going to be known as our hypotenuse, right? It has a more specific name. Just like if we have a square, it's technically a rectangle, but we're going to call it a square. Same type of thing. This side is adjacent to angle B, but it's our hypotenuse. So that's more specific. That's what we're calling it. Awesome. So our tangent of angle B would be AC over BC. And if we had numbers, we'd put those numbers in there. Cool. Now, we also have something called our cotangent. So the cotangent of an acute angle in a right triangle is the ratio of the length of the side that is adjacent to our reference angle to the length of the side that is opposite our reference angle. The expression cot A means the cotangent of A. So basically, what we could say is the cotangent is just the opposite of tangent, right? So put a bullet point here. We could say cotangent. Actually, instead of opposite, we're going to put is the reciprocal pro of the tangent. Or in other words, we could say cotangent equals adjacent over opposite, right? So this is some notes for us here, right? Write this stuff down. It's easy to see, right? If you come back and look at your notes while you're doing problems, boom, there it is. You have an idea of what the cotangent is, right? So if we're looking at angle A here, the opposite side is still the same. It's going to be here, opposite. Our adjacent side, ADJ. So then the cotangent of A, right? So cotangent of A is going to equal our adjacent, AC, over our opposite, BC. So that is our cotangent of A on this this triangle. So basically, this is what we just did, right? We just did the same thing. I'm going to draw it all out again. Let me just use a different color. So once again, if we're using A as our reference angle here, we draw a line across, and that's going to give us our opposite side. Right next to it is our adjacent. And once again, mister, how do we know that's the adjacent? Well, across from our right angle is our special side. It's our hypotenuse. Wait. So that's not our adjacent, right? So then what we could say here, length of the side adjacent is going to be AC. Length of the side opposite is going to be BC. We get AC over BC. And that's our cotangent of angle A. So now we want to do this, but with values. So it says determine the tangent and cotangent values of both acute angles in triangle DEF. Leave your answer as exact values and rationalize the denominator. So we have a lot of work to do here. So first things first, it's asking us for both acute angles. So we need to figure out what is the value of angle E. Well, when we have a right triangle, all you have to do is say 90 degrees minus our other acute angle, which is 30. And that's going to give me 60 degrees. Right here, we're going to put 60 degrees. So now what do we want to do? We want to find the tangent and cotangent of each one. So just as a reminder, what I'm going to do first is say that we're going to just write our little notes here. So we're going to say tangent is opposite over adjacent, and cotangent is adjacent over opposite. Right? So these are just flipped. Remember the reciprocals. Just so I have my notes there so I don't have to flip back and forth. Now, what do I want to do? Let's start. We're going to do purple, right? And purple is going to be with right here. This is going to be my 30-degree angle. So for my 30-degree angle, purple, we're going to say that this side is my opposite, which means that this side is my adjacent. So for my tangent, so I'm going to put tangent of 30 degrees equals opposite over adjacent, which is going to be 24 over 24 radical 3. Now, one thing that we have to do is we have to get this radical out of our denominator here, right? So what we could do is multiply the top and the bottom by radical 3. How we get rid of it, which is going to equal 24 radical 3 over 24 times 3. And the reason I have 24 times 3 here is because we're going to do something before we multiply this. What we notice is we have a 24 up top and we have a 24 down below. What happens is they will cancel. So what we're really left with here is radical 3 over 3. Boom. And that's our tangent of 30 degrees. Now we want our cotangent of 30 degrees. And our cotangent of 30 degrees is now adjacent over opposite. So for purple, we go to our adjacent, which is 24 radical 3 over our opposite, which is 24. Now, we don't have to derationalize or rationalize the denominator because there is no radical in our denominator. So we don't need to do this multiplication step. All we have to do is simplify this. And since we have 24 up top and 24 down below, they cancel, which is just going to leave me with radical 3 as my answer here. So the cotangent of 30 degrees is radical 3. Awesome. And now, since I already wrote my number in red here, we're going to use red for my 60-degree angle, or angle E. So in red, if we go and find the opposite is now this 24 radical 3. So we're going to say op. And my adjacent will be the 24 feet, A, D, J. Now, remember, purple is for my 30-degree angle. Red is for my 60-degree angle. So now let's write our tangent and cotangent. So we could say the tangent of 60 degrees is going to be our opposite over adjacent. So we're going to get 24 radical 3 over 24. Hey, this feels really familiar, kind of like the one we just did. So these 24s cancel, and our answer is radical 3. Hey, that's the same answer as our cotangent of 30. It is. That is true. This is a little pattern we're going to realize. And then our tangent of 30 is equal to the opposite of that. So we're going to say not our tangent. Whoops. We already did tangents of 30. What I meant to put was cotangent of 60. Sorry about that. So our cotangent of 60 is the reciprocal of this, right? So it's going to be 24 over 24 radical 3. You know, just like we had with the tangent of 30. Whoa. So just like that, we have to rationalize the denominator. We're going to multiply the top and the bottom by radical 3. When we do that, up top we get 24 radical 3. Down below, we're going to have 24 times 3. 24s are still going to cancel, and we're going to be left with radical 3 over 3. Just like our tangent of 30. So what do we notice? For these angles, they're like opposites of each other. My tangent of 30 is equal to the cotangent of 60. The cotangent of 30 is equal to the tangent of 60. They're like opposites, and there's a reason for that. It's because they're complementary. Complementary angles are basically opposites in our trig world, right? So they're going to be opposites of each other in the trig world, which means that their tangent and cotangents are going to be opposites with each other. So now let's see a problem. Here we have a problem. It says a proposed wheelchair ramp is shown. Compute the run of the proposed wheelchair ramp. So our run is this length down here, the base. We're going to put X there because that's what we want to find out. So now we have an angle here that's going to be our reference angle. So let's figure out what we have. We have our opposite side of our reference angle, which is going to be this 24. And then we have our adjacent side, which is X, ADJ. So we could write our tangent ratio for this. Remember, the tangent of something is the opposite side over the adjacent side. So let's set this up. We're going to say tangent of our angle measure, so 4 degrees, equals our opposite over our adjacent, right? So we're going to put opposite up top, which is 24, over our adjacent, which is x. So now we're using our trig ratios to solve problems, right? What we could do first is we could turn this tangent of 4 into a decimal or a number, but we're going to need our calculator. So once again, I highly suggest using the scientific decimals calculator. And what I'm going to do is I'm going to drag it onto screen here to show you how I use it. So here, you'll see the decimals, right? And I don't have anything typed in right yet. Sorry, let me drag this to the side, right? And we want to figure out the tangent 4 degrees. What is the tangent of 4 degrees? So you'll click up here where it says function, find tangent right there, boom. And then you just type in, go back to main, you click 4. But one thing we have to realize here is it says degrees here. You want it in degrees because there's something else called radians, and that's not what we want. We don't want radians. Look at the number change as I flick this toggle. Degrees, radians. They're so different. Bigly different. Lol. They're very different. So we're going to keep it in degrees. That's what we want to work with because our number's in degrees. So the tangent of 4 is equal to this number here, 0.06926. So we're going to round that to 0.07. So we're going to round this to 0.07. So what we could say, instead of having tangent 4 here, we're going to put 0.07. And that's the number we're going to work with. And it's still equal to 24 over x. But now, how do we solve for x? Well, it's in our denominator. So we're going to multiply both sides by x to get it out of there, right? So we're going to have something that looks like this. Here, they're going to cancel. On my right side, they cancel. On my left side, I'm going to have 0.07x. Because when I multiply it, this is how we write a number and a multiplication. Even if it's a decimal, you just put it in front. Equals 24 because these canceled. And now, last but not least, we just divide to get rid of this number by 0.07. 0.07 on both sides. On my left side, they cancel. And I'm left with x equals, and we just have to plug into our calculator. We do 24 divided by 0.07, and it's going to give me a number. That number is 342.8, and we're going to round to our hundredths place, our second decimal here, and it's going to be 86, and that's going to be inches. And that is our answer, 342 inches, 342.86 inches. There's our answer. And we used our trig ratio to find it, right? So guys, once again, I know I'm throwing a lot of stuff at you today. If you are confused, pause the video, raise your hand in Teams chat, send me an email, send me a message, whatever you have to do. Comment down below. Whatever you have to do, and ask a question. It doesn't hurt to ask, and I will be there to help you. But let's keep going. Now we have 2 more problems, right? So once again, we want to find out this one here. Whoops, this one here. And we're using the same angle. We have 2 more, and we're using the same angle. So we already know how to set this up. We have our opposite, and we have our adjacent, ADJ. So we could say the tangent of 4 degrees equals 20 over x. And we're going to do the same thing as last time. Now, we already know what the tangent of 4 degrees. From our last slide, we figured it out. That's equal to 0.07. So we're just going to swap that out. Equals 20 over x. Once again, and guys, a trick, if you have your variable in your denominator here, it's really just going to end up looking like this. And when we solve it all out, we're going to get x equals 20 over 0.07. They swap places. That's how it's going to end up working. But then we could say that x is equal to 20 divided by 0.07. So we just plug it into our calculator. So we do 20 divided by 0.07. And it's going to give me a number. And that number is 285.71. Perfect. And in my next one, we have the same thing, but now our opposite side is our variable and our adjacent side is our number. So when we set it up, we get the tangent of 4 degrees equals y over 100. This one's actually going to be easier. When we swap out our tangent of 40 degrees again, we plug it into our calculator. It's going to give us 0.07, just like it has been. And we're going to get y over 100. And for this one, all we have to do is multiply by 100 on both sides. Right? Because it's going to get it out of the denominator here. And what this will give us is y is equal to 7 inches. And there is our answer, right? So once again, what am I doing to get this 0.07 here? We're just plugging in the tangent of 4 degrees. You go to your calculator and you plug in tangent of 4 degrees. And if you're having trouble with your iPhone calculator, your Samsung calculator, whatever your phone calculator is, I highly suggest for this class, just download the Desmos Scientific Calculator app, right? So if you just type in Desmos, Desmos, it'll pop up on your app store. So now let's talk about our inverse tangent or the arctangent, right? It goes by both names, like fancy like that, it has 2 names. So the inverse tangent of x is defined as the measure of the acute angle whose tangent is x, right? So in order, what it really means is if we have both our sides, so if we're given both the sides and we could set up that ratio, that fraction, we could do our inverse tangent to find out the measure of the angle. That's basically all it is. And now the big thing that we have to do here is if you have a graphing calculator, if you have a calculator, our inverse tangent button looks like this. Tangent with that little -1. That little -1 means inverse. So if we look down below, it says in right triangle ABC, if tangent of A equals x, then the inverse tangent of x equals the measure of angle A. So let's see a problem what this actually means. Here we have an example, right? And it says, we have an example. It says the tangent of A equals 15 over 10, right? Because for A, 15 is my opposite, 10 is my adjacent. So the tangent of A is 15 over 10. If we want to find out the measure of A, what we could then do is use our inverse tangent, right? So basically, it's like we're getting rid of this tangent here. So it's like we're applying it to both sides. So we're saying inverse tangent of tangent A, they cancel, right? Inverse tangent and tangent, they cancel. So we get A. And then here, we get tangent inverse of 15 over 10. You just plug that into the calculator, and it gives us 56.31 degrees. And there we go. You got your answer. Let's try this with B. So now we want to get it with angle B. So first, let's write our tangent of angle B. So remember, tangent is equal to the opposite over the adjacent. So what does opposite be? Opposite, which means that here is my adjacent. So when we write this, we get tangent of B equals 10 over 15. Now we got to do our tangent inverse to get rid of this. So we say tangent inverse of tangent B equals the tangent inverse of 10 over 15, right? On this side, they cancel, and I'm just left with B equals, and we plug this into a calculator. So once again, let's look at our Desmos calculator. If I have my Desmos calculator like I have here, we click on this function button, and you'll see your tangent inverses there. We're going to click tangent inverse, look back to main, and then we're going to do 10 divided by 15. And this looks exactly like what we have written on our PowerPoint slide. So then it says it's equal to 33.69. So back over, and we're just going to write our answer is 33.69 degrees, because this is an angle measure. So angle B is equal to 33.69 degrees. And we used our tangent inverse. So reminder, the tangent inverse is to find the angle measure of our angle using the ratio of tangent. So let's try to do this once again, but now with angle E. So angle E is the angle that we're trying to find. So start out, we know that our tangent is the opposite over the adjacent. So which one's opposite here? You put your finger on E, and we drag it across, and it points right to 3. This side is opposite. Opposite and across, they mean the same thing. Our adjacent is right next to it. A, D, J. Adjacent next to. Now we can fill this in. So we can say tangent of angle E is equal to 3 over 8. And now we just have to find our tangent inverse. So we do tangent inverse of tangent E equals tangent inverse of 3 over 8. On our left side here, the tangent inverse and the tangent cancel. We're just left with, hey, E. And then on our right side, we have to plug in our calculator. So I'm not going to show it this time. We all should know how to do it by now. I showed you multiple times. We do tangent inverse 3 divided by 8, enter, and it's going to give me, and we're going to round to our hundredths place again. We get 20.56 degrees. So angle E is 20.56 degrees. Awesome. So now let's take it to a word problem, right? A real life problem. Movable bridges are designed to open waterways for large boats and barges. So they open up so then boats and barges could go through, right? When the bridge moves, all traffic stops. Maximum height of the open bridge deck of the movable bridge shown is 37 feet above the water surface. The waterway width is 85 feet. We want to calculate the angle measure formed by the movement of the bridge. So if we want to find the angle, we should already be thinking tangent inverse. But first, let's set up the tangent. So for this one, we'll say the tangent of x, right? But let's label it. We have x, we draw our finger across, and we get to 37 is my opposite, which means 85 is my adjacent. We say tangent x equals 37 over 85. And then we have to take the tangent inverse. So we say tangent inverse of tangent x equals tangent inverse of 37 over 85. Tangent inverse and tangent cancel. So we're left with x equals, and then we plug this into our calculator again. So once again, if you're on Desmos, you click the function button, you click tangent inverse, click main, and then you just type in 37 divided by 85. You click enter, and we get an angle measurement of, and once again, we're going to round it to our second decimal place. We got 23.52 degrees. And there is our answer. So this bridge goes all the way up 23.52 degrees in order to open up fully. And once again, we use our tangent inverse to figure that out. Whew! Man, that was a lot of information. I know it, right? I had trouble with this stuff in high school also. So guys, once again, if you are struggling or if you're confused, rewatch a section if you need to. Ask me questions if you have to. Ask Miss Harris questions. Ask your teacher questions if you're not in either of our classes. Or drop a comment down below. But let us know. We are more than happy to help. We understand that this is super confusing. This is the first time you're seeing it. So ask for help. Let us know. Make sure you take good notes. Rewatch this if you have to. And I'll see y'all next time. Peace out, everybody.